All right. Well, welcome. This is December 31st, 2020. And so we're facing a new year, and we might as well just say 2021, we're going to kick your ass this year. Alrighty, so we are on episode 7. And in episode 7, what we're going to be talking about is the Laramide Uplift. Okay, let me explain. About 12 years ago, when I moved to this area, as I was driving down 287 west of Fort Collins, kept coming across this styration of geology. And basically what it looks like is you got your regular hills, but you'll see that there are very pronounced layers of sediment. And that those pronounced layers are limestone, which is gray, and sandstone, okay, which is reddish brown. Okay, but what you'll find is that as you take a look at the Laramide Uplift, there's numerous layers, and it's always limestone, sandstone, limestone, sandstone, limestone, sandstone. It's always the same thing all the way down. And we know, in talking with our good buddy Tom Peden, that there is at least 7 layers, 7 different layers, okay? Each one having limestone and sandstone. And so we asked him, since he's the resident geologist up here, and he's lived here his entire life, and he's now in his 70s, what that is. He's the one that identified it, is limestone and sandstone. So we're going to be talking about the Laramide Uplift. It's the Laramide, you'll see in the maps that we present tonight, where it gets its name. The uplift part is that when you take a look again at the side view, you'll see a number of valleys, and then you'll see a giant uplift, and then that valley continues on. So basically what happens is somewhere along the line, the lithosphere broke and raised up sections of this geography. And here in Red Feather, it's pretty amazing. So again, we're on episode 7, Laramide Uplift. Keep in mind, we're going to be doing this today. However, Tommy has gout, so he's not going to be doing a whole lot of drinking, which means that for the first time ever, I may be able to outdrink Tommy. Okay, so just to let you know, I'm here at 6.
Holy shit.
Okay, and 1 beer. Where are you at?
1 shot.
1 shot?
And no beer. I'm still drinking the first.
Okay, so half beer.
Holy cow.
Okay, so you're there now. And again, I'm going to take advantage of this because that has never happened before. Alrighty, so the Laramide Uplift. And so at this point, let's get a picture of the Laramide Uplift.
Oh.
Alrighty. So again, I have been going by this Laramide Uplift for about 12 years now, and I've always wondered what the hell happened here. I'll give you an example, an experience that I had. My brother, who is 4 years older than me, has a master's in history, speaks 5 languages, been all over the world. And he came through here one day on his way to Laramie. And when he found out that I was moving up to this area, he said, I will never step foot in that area again. Because he saw it and he thought that what this was the sign of a major earthquake. And really, that's what happened. So we're going to talk about that. Okay, but the question is, why did the Laramide Uplift happen? And why is there limestone? And why is there sandstone? Okay, so Tommy, what do you need in order to have limestone?
Ocean bottom.
Ocean. You need to have an ocean to create limestone. Have to have lots and lots of water. The way that Tom Peterson explained it to us is he says basically what we were seeing is we were seeing thousands of years of ocean and then thousands of years of dirt, wind, blowing dirt around or mud. Okay? And so the question is why? Why the hell is that going on? Here's the funny thing about the Laramide Uplift. These striations of geology that we're seeing, the differentiations between limestone and sandstone, is not a local issue. It goes all the way down through the Colorado Plateau, on down through the Grand Canyon, and then continues south all the way down through South America. Okay, so whatever it was big. It was absolutely huge. All right, so we're going to talk about that here for a second. So let's just look at a visual aid here of what the Laramide Uplift is doing for us and why it's so great to be here and actually see it. Tommy, hand me my my little yes, the paper towel and a knife. We're going to do a visual aid here. Okay, so just to give you an example of what it is, we're going to take this orange.
Hey, orange! What? What is it, orange? Knife. Huh?
Okay, so basically this is what the Laramide Uplift does. It gives us an example of the many different layers that are taking place in geology by lifting up a section of it so that it's exposed. And by the way that it's exposed, we can not only tell what kind of geology it is, but we can tell how old it is as well. So that's why the Laramide Uplift is so great. Okay, so really the question is why? Why do we have those different layers? Okay, well, Tommy already said, in order to have limestone, you have to have ocean. That means that the Laramide Uplift, which is at an elevation of about 7,500 feet, you had to have ocean here. Okay, 7,500 feet above what? Sea level. How the hell did the ocean get up here? Now, we know it was the ocean, okay, because we have a number of fossils that we found. Tommy was in contact with someone in Wyoming, again, about this sea level, of who had found a fossilized turtle on his property, his private property. And that turtle was bigger than my F-150. Okay, and I don't believe I got pictures of it, but we need to put that in there. Okay, and I know in the Prostega, and I can't remember the name of the other one, which goes back to 85 to 100 million years ago, according to geology, their dating, that they have to have ocean level of about 60 to 90 feet in depth just to be able to swim through it. That's how big these turtles are. Okay, how did we get ocean here to the 7,500 foot level? So in the Laramide Orogeny, the way that scientists, geologists explain it is that, yeah, you have to have ocean here, but what you also have to have is you have to have a continental plate that is being, and a subduction of an oceanic plate. And what happens here is that oceanic plate goes through in the lithosphere and it creates pressure upwards, and that is what forms mountains. Okay? All right, so there's a picture of the Laramide Orogeny. Now take a look at that picture. We see the oceanic crust. It's a subduction zone. Goes under the continental crust, which in this case is the North American plate. and it formed the Rocky Mountains, right? All right. So, what is obviously missing from that explanation? Now, I've looked this up, and I've come across hundreds of pictures of how this happens, and it's always the same thing. What is obviously missing from that picture? The Sierra Nevadas.
Huh?
Okay, so what they're telling us is not only is the subduction plate going under the continental plate, creating the Rocky Mountains. Okay, what about the Sierra Nevada mountains? Okay, the Sierras. Hike these many, many years. Okay, their explanation is showing that the ocean had to be on the western slope of the Rocky Mountains in order to form that. They're saying that this subduction zone has to go at least, I'm going to put here, approximately 1,200 miles underneath the continental plate to create the Rockies. Does that make any sense? I can understand if it created the Sierras, because then that picture would be correct. They're saying the ocean had to be on the western slope of the Rocky Mountains. Okay, well, it turns out they're right. It absolutely is correct. So if we go to the Laramide map, the other one that you had, you'll see that indeed the ocean used to look like this. Okay, you see the Rocky Mountains there along Texas, New Mexico, Montana, Alberta, all the way up into the Canadian Rockies. You'll see that the ocean covered the entire central part of the United States, left the Appalachians there, goes all the way up to Hudson Bay in Canada. So the ocean was in a different spot. It ran a different way than what we're accustomed to now. But what that doesn't change is this. How the hell did the ocean get to 7,500 feet in elevation? This is the question that just kept on bugging me. Just kept on bugging me. Obviously, the ocean was in a different place, okay? So, there's only one way. The question is, how did the ocean get up to this level? Well, I mean, they're going to say, well, millions of years ago, the subduction zone created pressure and moved all of this up 7,500 feet above sea level. Okay, I'm going to call bullshit on this. Okay, the reason is this. There is no way, with all that pressure coming up, plus all the erosion that's coming down, that these fossilized skeletons from 85 to 100 million years ago would be in one piece. And this is the way that they're finding them. There's no way that you can take something as fragile as that, move it 7,500 feet up in elevation without completely destroying it. Okay? So, there's got to be another reason. And the reason falls into the catastrophe cycle that we're talking about. Okay, we're going to come back to this in just a second. Here's the catastrophe cycle. Catastrophe cycle is that every 12,000 years, approximately, every 12,000 years, the sun novas. Okay, and what that does, we know that stars can nova. There's many, many stars out there now. They're just finding out are repeating novas, meaning that they blow up, the sun doesn't disappear, it just relights and keeps going again. Okay, and when that happens, the Earth, let's do kind of a, okay, we know that when that happens, that the rotation, the magnetic rotation of the Earth reverses. And when it reverses, that creates catastrophe. And that's why when we look at archaeological discoveries, we keep finding them at these 12,000 year marks. 12,024, 36, 48. and so forth. Okay, so we know that this happens repeatedly. Okay, so this is what we're talking about. So how does the Laramide orogeny fit into that? Okay, well, let's take a look for an example of what made me start thinking about this this theory that we're going to talk about tonight. Okay, so basically what archaeologists have found is this. Back about 12,000 years ago, at the end of the Clovis era, the Clovis era, basically it's named after Clovis, New Mexico, where the first archaeological site was of ancient North American Indians. And what they found was that there was a developed civilization here in North America 12,000 years ago that suddenly disappeared. Okay? The black mat is this. Basically what it is a layer of charcoal that you'll see on the side view that's covered by layers of sedimentary rock. And what they've discovered is that that layer of charcoal means that something happened. Something caught on fire, big giant layer of charcoal on it, and then all of a sudden, what preserved these black mats was there was an influx of water to cover it. So it caught on fire, influx of water to cover it. All this charcoal was there underwater, and they keep finding these black mat layers. Where do they find them? They find them at the Clovis era archaeological sites where there was civilization. Okay, now we look at the map. So I'm looking at this map and I'm going, what the hell? It seems to me that they're all congregated in a band. And that band is running north to south. In that little bit of an area, what is that, about 1,000 miles apart?
Oh, yeah.
Okay, so we take a look at Earth. We see this 1,000-mile band. Okay, north to south, where all these black mat sites show up. Okay, and I know that there's a number of them in Siberia. They've found them in China as well. What does that look like to you? That is an equatorial band. But wait a second. The equator runs west to east. What happened is that when the sun novaed, and there was a reversal, what that means is that the spinning of the Earth had to slow down, stop momentarily, and then go the other direction. What's going to happen? What's going to happen is whatever part of the Earth is facing the sun, that's all going to catch on fire. Okay? Every bit of it's going to catch on fire. And we know that this happens because of all the glass beads, the tektites that we find, as well as this layer of charcoal that we're finding in all these black mat areas. But what this is telling us is that the equator was going a different direction. Okay, I don't know if it was a 90-degree shift. I don't know if it was a 30-degree shift. Okay, honestly, I can't tell you that. But what it does appear to happen is that this was the equator at one point, not what we're used to today. Okay, so now let's extend the lines a little bit here. All right, and in order for us to equate the map of the Laramide Orogeny, okay, what are we seeing here? We're seeing the ocean in a different direction, and it appears from this map, and they know this because of all the geological studies that they've done of everything, it appears that the equator was running in a different direction at this particular time. Okay? That the ocean continued on up, all the way up through North America in this case, up through the North Pole. Okay, how is that possible? Okay, how is it possible that the ocean can be that high? Because we know what the elevations are there. Okay? And then it dawned on me. And this is something I've known about for decades. And then just all of a sudden, the piece fell into place. The Earth is not round. Okay, I'm not a flat earther. This is not a flat earth thing. The Earth is not round. Remember, it's constantly spinning. It's constantly spinning in this direction at 1,000 miles an hour. What does that do? That creates centrifugal force. Okay, if you were to take a wheel and you were to put it in water and then immediately start turning it, what you'll see is the water will spit out from the middle of it in this direction. Okay, that's caused by centrifugal force. So, because of that, the Earth is not round. When they do satellite imaging, the Earth is really more this shape. Why is that? Because the North Pole and the South Pole are spinning slower than the equator. This is what's called equatorial bulge. 2/3 of the Earth is water. 2/3 of the Earth is ocean. Because it's constantly spinning in that direction, what you will find is that the level of the ocean is higher in the middle than it is at the poles. It's called equatorial bulge. Okay, well, does that explain the 7,500 foot elevation? Yeah, it does. Why? Because the level of the ocean at the poles is 27 miles lower than at the poles, than at the equator. Okay, now you have to divide that in half, right? Because we're dealing with a sphere. That means the bulge at any given place on the equator is 13 miles higher than at those poles. Okay, let's go back to the nova event, the reversal. And at this point, this convinces me, and I'll explain why in a second, this convinces me that not only do you have a reversal, which I'm also convinced of, because I followed the geology for 5 days to see that last year, and I can see the mud flows of the reversal, but there is also a shift. So now if you take this equatorial bulge, you change the rotation of the Earth, you are going to have the equatorial bulge go from here, Antarctica, to the Arctic. Antarctica. Okay. So now, all of a sudden, here, sea level is going to be about 13 miles higher than it was before. Okay, 13 miles equals 2,580. What's 13 times 2,580? That'll tell us how many. I'm sorry, I love math, but 13
Probably about 33,540.
33,540 feet difference in the level of the ocean because of the change in the equatorial bulge. Will that satisfy the 7,500 elevation that we're finding all of these sea mammals at? Does this satisfy all the fossils of sea life that we find even in the Himalayas, way up at the top of the mountains? Yes, it does. Because it's easy for the elevation to change to where that map shows right now, to where it turns the Rockies, the Sierra Pacifics, the Appalachians, the Andes into nothing but an island chain. So when you're talking about these different civilizations that they keep finding at the 12,000 year marks, it's easy to see how, one, they disappeared, and two, how the survivors had to move to different areas in order to survive. They would have had to. Okay, so this is very important. Understanding the change in the equatorial bulge is very important. Why is that? Because it gives us the ability to understand where to go for survival. Where do you go? Remember the Laramide Uplift? Limestone, sandstone. Limestone, sandstone. Wherever it is that you go, historically, geology tells us you gotta be above the top layer of the limestone. Why? Because it's never seen ocean. You gotta be above where the ocean was. Now, I'm gonna brag a little bit. We're in Red Feather. Red Feather is at an elevation of 8,500 feet. Okay, what do we find the difference between the Laramide, just this 1,000 feet, the Laramide Uplift, and Red Feather? Well, here's the old glacier, which we know was a mile high. Okay, we have the Laramide Uplift that gives us the sandstone. Then you have to go all the way up to the top of the mountains, which is 8,500 to Crystal Lakes is running about 9,500 feet. What do we find? Just above that last layer of limestone is all granite. Meaning, because there's no limestone deposit, we're in granite. This, where we're at, has never seen ocean before. It was a part of the island chain. What do we call that? Disintegrating?
Decomposing
granite.
Or decomposing schist.
Yeah, okay. So that decomposing granite means, because we're not seeing limestone or sandstone, this has never seen ocean before. So if you go back to the 12,000 year marks, all the times, how many times did we say? It was 7.
5. Is it 7?
Yeah, Tom told us there was at least 7.
Wow.
7 or 9, I can't remember off the top of my head. Okay, so for the past 7 to 9 times that this has happened, water never got up here. Okay, the proof is what? The proof is that we know the oceans have been up here before. It's proven by the geological maps. It's proven by the geology of the Laramide Uplift. And that's the only thing that we can take from this, is that it's never seen ocean before. You got to get above the limestone. You got to get above the sandstone. You got to get above the gypsum. You got to get above the basalt.
That's why there's no natural caves.
Yeah.
Because glacier melt makes those caves.
Right.
The glaciation wasn't that high.
Yeah.
So that's why there's none of that up here.
Okay, so that being the case, and you look at the map, and even though it's along the Appalachians, would the Mammoth Caves be a good place to go? No, they were formed by ocean water. Okay, that's how those caves got there. Any cave system, whether you're in Kentucky, in the Appalachians, the cave systems go all the way up through Virginia and up towards Canada. I think it's 400 miles?
More than that.
Yeah, more than that.
Yeah, they keep
that they've
discovering.
actually discovered.
Right.
Yeah. The cave systems in Missouri and Arkansas and what's next? The eastern edge of Kansas. Not a good place to be. You got to be above the last layer of limestone. Okay, so I'm just going to flat out tell you that if you've been following this, we've proven the catastrophe cycle, and we're not the only ones doing it, but this is where Tommy and I are different. This is where we break away from all the other explanations that you'll find, is that the geology is telling us the equatorial bulge moves, and that means there is a shift. Is there a reversal or a shift? The answer is both. Both happen. And you got to be prepared for it. You got to be above, wherever you are in the world, above that top layer of limestone. Okay, so again, here's what we're talking about. We talked about the reversal. Okay, so here's sea level. Here's the ocean. Okay, here's the break between land and water. Let's just call this the Pacific. Okay, and let's say that sea level, San Francisco is right about here. Okay, San Francisco is right about there. And then you got the Sierra Nevadas, the Colorado Plateau, the Rockies, and then it drops down through central United States, and then you got the Appalachians over here, and then the East Coast. You may think that standing right here is a great place to be. It probably is, okay? But even though these are sitting up at, well, let's go to the Rockies, in some cases 14,000 feet high, okay? Remember, you got all this water. In the Pacific Ocean, the average depth of the Pacific Ocean is 15,000 feet. Is that water enough to get up over the 14ers in the Rockies? Yes, okay, but it's worse than that, because the deepest level in the Pacific Ocean is 36,000 feet. Oh, I'm sorry, 36,000 feet in the Mariana Trench. Okay, this is only 14,000 feet. This is 36,000 feet. That's roughly 7 miles deep. Okay, now take a look at the map of the world. 2/3 of the world is ocean. Only 1/3 is land. So on a comparison basis, you got a lot more water than you do land. So during the reversal, okay, during the change, the reversal, all this water is going to come up this direction from west to east, and it's going to be more than enough to cover those mountain areas. So even though we know that the ocean levels settle out somewhere in this half range, about 7,500 feet, you still got the initial surge. Okay, then during the reversal, what happens? The Earth moves this direction, starts reversing the other direction. So at the beginning, it goes west to east, but then you get the 1-2 punch, and then all of a sudden, the water, when it reverses, is now going east to west. Except, what we're seeing here is that there is a shift. And if that shift is, say, 90 degrees, what's going to happen is that water is going to go this direction, okay, up towards Canada and the North Pole. We are talking near total destruction. The good thing is, obviously, we see civilizations at the 12,000 year marks. We see those changes. Humans have always survived. But you got to be prepared. You got to know not only where the ocean is going for a day, you have to know where it's going to land during the new equatorial bulge. Okay, now everyone, climate change. I'm going to go to climate change here.
God.
Oh my God, climate change is going off, and all this ice that's at the North and South Pole is going to melt, and it's going to raise the level of the ocean. Okay. Well, the good thing is we know how much ice is here and here. Okay, this is X. So when you take the world as we know it today, you melt all that ice. Is it enough to get up to the 7,500 foot level, which is the layer of limestone here? No. Look at this map. This map shows, and this is according to National Geographic, this is where I got it from, what the United States would look like if all the ice caps melted and all at once. You'll notice there that water level doesn't even get close to the level of the ocean that we showed earlier. Yeah, you're going to lose New Orleans, you're going to lose most of Florida. Don't move to Florida. You're going to lose parts of Georgia, North and South Carolina. New York's going to be gone. Okay, Boston, Halifax, all of that's going to be gone. Okay, you're going to it looks like the water level may get up to Houston, which is in the middle of Texas, but it ain't going to get to the center of the United States. San Francisco, yeah, that's going to be gone. Los Angeles, San Diego, most of the Baja California, that's going to be gone. But it is not going to get to the level that was shown in the earlier map. The only way that that's going to happen is if there is a shift and the equatorial bulge moves. That's the only way to explain all these fossils that we're finding at the top of these mountains. It's the only way it can possibly happen. Okay, now I have had a number of people that are talking about the catastrophe cycle. Some of them are very famous. Okay, Graham Hancock. I'm going to spell his name right this time. Randall Carlson. I hope I spelled it right this time. He's going to kick my ass. Ben Davidson. Okay, Doug Vogt. To name a few. But then we have some other people like Colonel White, okay, who wrote World in Peril. Okay, he was one of the first ones to come out publicly about this. Okay, all of them are talking about this catastrophe cycle. But remember when I said in an earlier episode, all of them were right, but they weren't 100% right? This is the one piece they're missing. The equatorial bulge. This is the only thing that can explain the geology. Now, we look at this, and we're going to be able to explain a lot of what these guys are saying.
Take,
Yep.
I don't remember.
Alrighty. Alright, take a little break. How many shots?
We both do 2 more?
2 more? I think it was 2 more. Yeah.
Yep.
And you're up to 2 on beers. I'm up to there. Okay. I'm still ahead of you.
I know. It's a lot harder now.
That's never going to happen again.
Damn it, man. Holy shit.
Okay. So, we were talking about how these other individuals that are talking about the catastrophe cycle, that they're right. As an example, Graham Hancock and Randall Carlson, they believe that the catastrophe cycle is because of meteor impacts on the Earth. And thing is, they're talking about the catastrophe cycle. They're talking about the right time range. The problem I have with meteorite impacts is that it's kind of happenstance. It's a chance. It's not something that is cyclical like we're seeing in the geology. Ben Davidson, Doug Vogt, they're both talking about the nova events, which is what I subscribe to. But the question is, in this particular theory and all the people that are talking about it, was it meteor impacts or was it a sun nova? I believe it's both. And the reason is because when we're talking about the magnetosphere weakening, the changes in the magnetic North Pole and South Pole, that's going to create an atmosphere in which, there's going to be a lot more attraction because the Earth is at its lowest defense right now, and it's getting lower for meteor impacts, like we saw on what was it, Levy Schumacher event on Jupiter. So I believe they're all right. They're just not 100% right. And when it comes to the equatorial bulge, here's the deal. I've read just about everything by Graham Hancock. Listened to a lot of Randall Carlson by now. I listened to and watched Ben Davidson just about every day because he posts every day. And so I've been following him for years. Doug Vogt, the same thing, been following him for years. Doug Vogt's got some great insights into some of the contributing factors of this, and he's really the first one that I found that was coming up with the 12,000 year cycle, and I was able to match that with both history and mythology. Okay, how many beers did I have? Okay, mythology. Okay, so I was able to line that up with that. Same thing with Ben Davidson, Graham Hancock, Randall Carlson. They're all talking about the same thing. Okay, but in following them for so many years, there's been a number of their theories that the shift in the equatorial bulge will explain. As an example, Graham Hancock talks about an ancient civilization in North America, which was here long before the Clovis era, and how their DNA ends up in Siberia, Polynesia, Europe, through the Europe, okay, and how it shows up through the Denisovians, the Polynesians, and the Solutrans. Okay, and basically that goes back to the 12,000 year cycle, 12,000, 36,000, 48,000, 60,000, so forth in archaeology. And he always puts in his books of how he believes that this lost ancient civilization, he believes that they started in North America and they somehow ended up in Eurasia. And then on the other side, you see a number of people that are talking about how the instead of the Northwest Passage of the ancestors of the North Americans coming over the Bering Straits down into North America 12 to 20,000 years ago, and starting the North American Indians and so forth, and then they spread out from there. Now they're looking at it as, well, maybe they came over from Europe on a land bridge from east to west and came down through Nova Scotia and on into North America. Well, here's the deal. When you're talking about the equatorial bulge, you're talking about the dramatic changes in sea levels, and which would also lead to the dramatic changes in land levels. Remember the map that we took a look at with regards to Laramide Orogeny. Basically, that would have turned the Appalachians and the Rockies into an island chain. Okay, now when you go down to South America, you realize that Brazil all the way up to the Andes, the Amazon is completely gone. Just the very peaks of the Andes, Peruvian Andes, Costa Rica, on down, is still above water, but it's an island chain. But on the other side of the world, Antarctica becomes a landmass when you change the equatorial bulge, which leads to Australia and Polynesia and Europe. So what that means is that by shifting the equatorial bulge after the magnetic reversal and the shift, you can see how it's easier for ancient civilizations to move from North America down Antarctica, up into Australia, and then into Eastern Europe. So that solves Graham Hancock's issue with the ancient civilization that was pre-Clovis. Okay, it solves how or conversely, how the Denisovians, named from Denisovia, Siberia, which dates back to 48,000 years ago, were able to come through that same land bridge over to North America to spawn the North American civilization. It could work either way. Okay, so in addition, Ben Davidson and Doug Vogt for a long time, well, even now, their differences is in Earth shift versus full reversal. I propose, from what I'm seeing, that both happened. Okay, because if you're going to have a full reversal of the Earth's rotation, it seems more likely than not that there's going to be a subsequent shift along with that. I think both is happening. When you talk about Graham Hancock and Randall Carlson with regards meteor impact versus Ben Davidson and Doug Vogt's nova, I believe that both occurs. And that occurs in a time period of somewhere between 700 to 1100 years. Okay, what I'm saying is that the nova is just the beginning. The consequences on the push me, pull you effect of the sun and earth is going to last this amount of times. And I base that not only upon the works of these four people, but predominantly upon the works of mythology. This is what I'm seeing in the big picture, is that turmoil on the earth lasts about 700 to 1100 years. Okay, now we can go back to one of the charts that we have here of the Younger Dryas. But if you take a look at the timeline of the Younger Dryas, you'll see that that's supported from the time that the earth got very, very cold, which was about 12,000 years ago, to the time that it sparked up again and got much warmer to the median temperatures that we have today. That span is about 700 to 1100 years. Okay, so now let's go back into something that has nothing to do with the excuse me, that has nothing to do with the catastrophe cycle, and that's what one of the first things that I noticed, came to understand, was the work of Colonel White. Okay, Colonel White worked for the I can't remember if it was Air Force or the Navy, but he wrote the book World in Peril. And in World in Peril, it was a military excursion up into the Arctic, and they began to do digging because they needed to learn, if the North Pole is moving all the time, we need to know that, because all of our missile defenses and so forth were dependent upon knowing where magnetic north was. They couldn't fire off a missile and get it to the target they wanted unless they accounted for that magnetic pole. And in his work in World in Peril, he began excavating, digging, doing core samples in the Arctic, and realized that what they had was that they had multiple layers of tropical vegetation. Okay, now that tells us a couple things. One is that because they have multiple layers, that we're talking about a cyclical events, something that happens over and over again. And on top of that, because we're talking about tropical vegetation up in the North Pole, that means at some point the North Pole had to be close to the equator. The equator today, basically, with the electoral, it's an election year. Okay, the equatorial bulge. We not only have to think about the equator itself, but we also have to think about the Tropic of Cancer and Capricorn. It's that entire range that basically is where we have this uplift due to the centrifugal force.
Do we vote on it?
Sure, why not? Does it mean anything?
Yeah, no kidding.
Okay, so multiple layers of tropical vegetation. So that tropical vegetation had to be near the equator. Okay, again, that lends support to what we're talking about here, which is different than anyone else that I'm talking about here, is that there is a subsequent shift that raises the oceans in places, lowers the ocean in places, which is the same thing as landmass building up, so that you get tropical vegetation at the North and South Pole. Okay, so I think we're dead on with the equatorial bulge and the shift of the Earth. I think we are looking at both a reversal and a shift. I think we're looking at both a nova, and because of the Earth's defenses dropping due to the magnetosphere weakening and the shift to the magnetic north and south poles that we're seeing going on right now, that it's all of the above. And it just makes perfect sense that that is what we're looking at. And for years I've gone back and forth on this. Is it one or is it the other? Because I've seen evidence for both. I think it's both. Is that still on?
Yep.
Okay.
On.
Very good. Okay, so again, let's go back to what we're talking about in the matter of survival. And we're going to do a whole episode on survival. Okay? Based upon this, you need to be above the top layer of the limestone and sandstone stratification that we're seeing all over the world. You need to be above that. You need to be in the granite. Okay? You need to be at the top of the mountains. And yes, because of ocean waves, the potential of that 2/3 of the earth covered in ocean covering the mountains, because remember, the amount of water that we have is nothing. The amount of land that we have above the water is nothing compared to the potential of the water. Okay, so where does that put us? Well, I just finished up the book Raven Rock. Okay, Raven Rock is the basis of the TV miniseries While the Rest of Us Die. And in there you will find that the U.S. government, based upon their plan to continue COG, which is continuity of government, their plans, they have built a number of underground facilities around the United States and have spent trillions of dollars on this. And this has been going on since 1940s, 1950s. Okay, if you read the book Raven Rock or watch the TV series While the Rest of Us Die, you'll understand fully what this is. Now, I 100% believe that the U.S. government has done all these underground bunkers that you will find all over the United States because of the nuclear threat after the Cold War. However, if they plan on using this as a means to survive a solar nova, reversal of the Earth, and shift, that's the dumbest thing I've ever heard. Okay? Because you're going to find that where these are located at, they're going to be underwater or under ice at the end of that event. That event goes on for 24 hours. The turmoil that it creates lasts for hundreds of years, but the event itself only lasts for 24 hours. That's how long it's going to take for everything to reverse. And when that happens, these people who go underground, either because of earth shifts, depth of ocean changes, the magnetic electrical effects that take place between the earth and the sun, they're going to be in the worst possible place for survival. You need to be above the limestone. You absolutely have to be there in order to survive this thing. Okay? And that is going to be a breakaway from all these other catastrophe cycle people that we're talking about. How did I come about it? I've been driving by it for 12 years. I've seen it every single day as I'm going down there. And it was my study of what's going on with my local geology that helped me to understand how to ask the right questions about this. And that being the case, I think that this is the most important episode that we've ever done. We've talked about the mythology. We've talked about the science. We've drank a lot of beer and taken a lot of shots. Okay? And this is episode 7, but I think this is the most important episode that we've ever done.